Tonight, something quiet moves through the dark, a thread of light slipping across the solar system as if it has been traveling far longer than memory. You don't see it at first. You only feel a soft shift in the sky, the kind that makes you pause without knowing why, as though a distant visitor has finally reached the edge of your awareness. It drifts without hurry. It behaves in ways nothing should, and somehow it finds you before it finds anyone else. Before we begin, if these gentle journeys help you slow down, you might like to stay for more. You can tap, like whenever you truly feel it. Subscribe if you'd enjoy more stories told softly, and leave a small thought or feeling below. I always read them, and they shape the next quiet nights we share. Now, let's drift. You let your breath settle, and the world around you settles with it. The room quiets. Your mind quiets. What remains is a gentle awareness, the kind that notices things usually swallowed by daylight. Somewhere above you, the sky carries a soft vibration. It isn't loud. It isn't even sound in the way your ears understand sound. It is the low, steady heartbeat of a planet wrapped in magnetic breath. Earth creates it every moment, a constant hum shaped by charged particles from the sun as they slide across the magnetic field lines, like fingers brushing the strings of an invisible instrument. No human ear can hear this music directly, but satellites do. In the cold, thin quiet above the atmosphere, NASA's swarm constellation orbits with patient precision. 3 identical spacecraft flying in formation, listening to the shape of Earth's magnetic field, the same way a stethoscope listens to a heartbeat. They detect currents moving through the ionosphere, the slow drift of the poles, the shifting pressure from the solar wind. Every second they gather numbers that trace a shield you live under without ever seeing it. You breathe again, the air feels ordinary, yet the protection around you is anything but. The magnetic field stretches from the molten outer core out into space, forming a vast cocoon of charged particles, the magnetosphere. Research shows it deflects radiation powerful enough to strip away an atmosphere the way it did on Mars long ago. Without this shield, every delicate system of your body would be exposed: DNA, cell membranes, even the electrical rhythms of the heart. It is strange to think the thing keeping you safe is completely invisible. Stranger still, that something from beyond the solar system is now passing through that shield's outer edge, disturbing it in ways no model predicted. Your thoughts drift to that traveler 3IATLAS, the quiet streak of light whispered about in observatories. Not quite a comet, not quite an asteroid. Moving too fast to belong here, yet moving too deliberately to be debris. Astronomers studying its path noticed something curious. Their equations expected one shape of orbit, but the visitor carved a different one, almost as if reacting to forces too subtle for instruments to interpret fully. You wonder what that means, though. You've barely begun to understand the sky. Curiosity has a way of expanding inside you, gently like light, soaking into the edges of a dark room. The darkness above Earth isn't empty. Far beyond, where air fades into vacuum particles from the sun, crash into the magnetosphere at nearly 1,000,000 miles per hour. When they strike, they compress the magnetic field on the day side and stretch it on the night side, forming a long magneto-tail extending millions of kilometers behind the planet. Every minute this shape changes. Every minute swarm records the shifting lines. And tonight, somewhere along that distant tail, something brushes against it. Observatories report faint irregularities in plasma patterns. Nothing catastrophic, nothing alarming, just unexpected. Like a soft ripple in a pond when you were certain nothing had touched the water. Data drifts down to Earth, changes in density, tiny oscillations, subtle shifts in the orientation of magnetic lines. Scientists suggest these are interactions with a body moving through the solar wind, a body that behaves oddly, even by interstellar standards. Odd because it brightens without warming. Odd because it changes velocity in ways too smooth to be random. Odd because its composition refuses to match known families of icy bodies. You let the idea settle inside you. A visitor crossing a boundary no object has crossed before. A traveler without a past. Some researchers describe its glow as anomalous reflectance behavior, not poetic, but precise. The light curves flicker with patterns that don't match typical comet rotation. In some frames, it brightens more quickly than solar heating should allow, as if material were shedding or flashing from beneath its surface in brief, sharp breaths. Imagine holding an object of ancient ice. You expect it to warm slowly in your palm, Instead, it pulses once gently before calming again. That tiny pulse would change everything you believed about what it was made of. The pulse 3IATLAS gives is far more subtle, but the feeling is the same. Astronomers analyzing spectrographic data see traces of compounds they struggle to classify. Not impossible compounds, nothing violating chemistry, but concentrations that imply processes unfamiliar to objects formed in the protosolar nebula. Grains altered by cosmic rays, ice reshaped by temperatures near absolute zero, materials older than the sun surviving untouched for billions of years beyond our cosmic neighborhood. A quiet realization forms. The visitor is not just passing by, it is carrying history. Your mind lingers on that the idea of something drifting through interstellar space for eons. No star to warm it, no gravity well to guide it, only the faint pressure of starlight and the soft push of plasma waves slowly sculpting its path. For billions of years, it belonged to nothing. Now, it is brushing the magnetic breath of the only world you have ever known. Your breathing slows. You feel the room again, though your thoughts remain far from it. Data from ESA's solar orbiter shows a rise in small-scale turbulence in the heliospheric magnetic field. These fluctuations likely have ordinary causes, solar wind streams interacting high-speed particles, overtaking slower ones. But scientists are careful. When an interstellar object is present, even subtle changes draw attention. It isn't fear, it's curiosity sharpened by possibility. You picture the object drifting through the solar wind, a fragment of ancient material wrapped in a halo of charged dust. As sunlight strikes it, electrons escape its surface, creating a faint electric field. This happens to all small bodies, but something about this glow is different in degree, not kind, slightly brighter than predicted, slightly more responsive to plasma pressure. Not extraordinary enough to rewrite physics, just extraordinary enough to make you lean closer. A question emerges quietly inside you, not spoken, not urgent, more like a soft ache of wonder. What story does something this old carry with it? You won't know tonight or even tomorrow, but the question settles in your ribs, the way starlight settles on the ocean gently, without needing an answer yet. Back on Earth, magnetometer stations record tiny pulses that match the timing of solar wind compressions. Nothing unusual, nothing outside normal ranges. Yet knowing something unfamiliar is passing through. That same wind gives each pulse a new kind of weight, not heavier, just more meaningful. The faint memory of the visitor moves with you now. Your awareness follows it patiently, as though you were drifting beside it through cold, silent space. No air, no sound. Only the steady pressure of light nudging everything forward, including you. The universe becomes strangely intimate in that stillness, less like a vast emptiness and more like a quiet room with ancient stories resting on every surface. In moments like these, your thoughts become slow, deliberate, easy to hold. You imagine Earth's magnetic field stretching outward, tracing beautiful loops from pole to pole. Research shows those loops shift constantly as molten iron churns beneath Earth's crust, creating currents that generate the magnetic field itself. A restless ocean of metal, moving at speeds up to tens of kilometers per year, shaping a shield strong enough to hold back the sun. Inside that shield, you lie safe. Outside it, the visitor continues its silent motion. Its brightness changes again just slightly as captured by new telescopic images. Analysts describe the change as a non-gravitational acceleration. Signature similar to how comets behave when outgassing, except the pattern doesn't match typical jet releases. The force is steadier, smoother, lacking the chaotic bursts comets usually show. Some believe it's due to sublimation of hypervolatile ices. Others suggest dust-driven reactive forces. No one agrees yet, and that lack of certainty feels strangely comforting. Science grows in the spaces where certainty thins. You feel the same way now, open, curious, unhurried, floating with the mystery rather than chasing it. Drifting through a dark so gentle it almost feels warm. Above you, the visitor moves closer to the inner solar system, brushing regions of space dense with charged particles. Every shift in solar wind pressure shapes its glow anew, creating patterns like ripples of light sliding across frozen stone. You imagine placing your hand against that ancient surface, feeling the cold of time itself. Not frightening, just deep. It's strange how something so distant can feel personal, as though its long journey has been waiting for your awareness to meet it. Lights from satellites continue their quiet measurements. Data streams from deep space telescopes. Observatories refine coordinates. Scientists discuss possibilities over midnight coffee. Yet, in this moment, none of that feels rushed or urgent. The sky has set a slower pace, and you follow it easily. Somewhere in the magnetotail, a new fluctuation appears. Small, brief, possibly nothing. Possibly the first hint of the visitor interacting with magnetic structures stretched thin by solar wind. You picture those structures bending softly like branches in a quiet storm. Nothing breaks, nothing alarms. It is simply the universe shifting around a new presence. Your breath follows that rhythm. In, out, calm. A gentle awareness settles deeper into your chest, as if the space inside you is widening to hold the story unfolding above the world. The traveler continues its approach. You continue your quiet listening. Both motions feel connected now, one through space, one through thought, drifting along the same invisible thread. A thread that leads deeper into the mystery waiting in the dark. And in that dark, something begins to glow, just a little brighter. You stay still for a while, letting that quiet glow linger in your mind. It feels almost like someone touching your shoulder gently from very far away. Not to startle you, but to remind you that the universe is closer than it seems. A closeness you don't notice during the noise of daytime, but here in the calm, it becomes unmistakable. Your awareness drifts upward again, past the air, past the last traces of blue, into a darkness that isn't empty at all. Sensors watching the sky pick up faint threads of information, tiny fluctuations in brightness, delicate shifts in reflected sunlight, patterns so subtle they could vanish if a single number were rounded differently. Yet they remain, soft, persistent, like a whisper trying to reach you from the edge of something ancient. Astronomers call them light curves, the fragile waves of brightness that reveal how an object rotates in space. Most light curves behave like breathing, predictable, rhythmic, steady. But the one belonging to 3IATLAS trembles, not violently, not in a way that suggests danger, just enough to say, I am not shaped the way you expect. You imagine a distant fragment turning slowly under starlight, catching photons on uneven surfaces, its rotation sculpted by eons of drifting through plasma winds that rarely touch anything. Those winds would sand it down, unevenly, carve asymmetries, imprint memories on its body, the way tides carve stories into the coastlines of Earth. The faint trembling in its brightness may be nothing more than that. Or it may be evidence of something deeper, density variations, fractured layers, pockets of ancient ice, holding secrets of worlds long gone. Scientists studying the data stay cautious, but you sense their excitement underneath every careful phrase. In moments like this, you hear the universe exhale. Each new measurement arrives from observatories scattered across the planet, from deserts, mountaintops, frozen plains, places where the air is thin and the stars feel almost reachable. Telescopes there watch the visitor with mirrors polished so perfectly that a single speck of dust could shift the readings. Yet the readings remain consistent. A brightness too smooth for a comet, a rotation too unstable for an asteroid, a path too deliberate for debris. You let these thoughts drift through you, light and effortless. The strangeness of the visitor does not create fear inside you. It creates something softer, a quiet anticipation, like holding a letter you haven't opened yet. Somewhere above Earth, radio antennas turn their dishes toward the coordinates where the object moves. They don't expect messages. They don't listen for words. They listen for the faintest changes in radio noise, the static of the cosmos, hoping to find patterns that reveal the visitor's physical nature. Many objects produce this kind of noise, charged dust, ionized gas interactions with solar wind. But this one creates a signature with small periodic dips, barely there, barely noticeable, yet unmistakably real. It feels like watching someone breathe in the dark while they sleep. Gentle rises and falls, so soft, you only notice because the stillness around them amplifies everything. Research suggests these dips may come from rotational wobble or material shedding from the surface at slow intervals. Nothing extraordinary yet, but you feel the pull of those details, the gravitational tug of mystery wrapping itself around your imagination. Somewhere in the silence between those dips, your mind begins to wander across the object's origin. Not to create theories, those belong to scientists, but to feel the distance it has traveled. Light takes years to cross the space it once called home. Dust around it has been shaped by cosmic rays since before Earth cooled enough to grow oceans. Its surface has witnessed nothing and everything all at once in the endless quiet between stars. You close your eyes for just a moment, and the darkness behind your eyelids resembles the darkness it has drifted through. Not the heavy kind, the peaceful kind. Your thoughts slide effortlessly into the idea of deep time. Some grains on its surface may have formed inside the outflows of dying stars, carried outward by the stellar winds of centuries-long explosions. Imagine that fragments of stardust enduring blasts that could unmake worlds only to cool, settle, merge, and begin a journey without purpose, without direction, without an end. Until somehow, they found themselves entering the thin boundary of a solar system filled with warm planets and restless minds. You breathe again slowly. More data arrives from the Pan-STARRS survey images, comparing subtle shifts in the object's position. Astrometry shows that its course curves slightly in ways unaccounted for by simple gravitational influence. That small deviation glimmers in your thoughts like a spark in a dark room. Scientists describe it using quiet language non-gravitational motion, consistent with outgassing behavior, though atypical in pattern. They could have said, something pushed it in a way we do not yet understand. But science whispers its mysteries gently, just as you like them. You feel the whisper travel across your skin. The visitor moves closer to regions of space where the heliospheric current sheet, a vast rippling surface formed by the sun's rotating magnetic field, grazes past. This sheet is thin but enormous, stretching billions of kilometers and undulating like slow cosmic waves. Each undulation changes the polarity of charged particles passing through. As the object drifts through one of those folds, its brightness shifts again, just a hair. Not enough to alarm anyone, just enough to say it responded to the environment around it. You imagine your hand sliding through water, feeling gentle resistance that changes with every tiny movement. The same sensitivity lives in that visitor, not as intention, but as vulnerability. Objects shaped by interstellar travel become delicate in ways you might not expect. Cosmic rays carve microscopic channels in their surfaces. Thermal stresses fracture them like old pottery cooling too quickly. Ion bombardment alters their chemistry grain by grain. A body wandering for billions of years wears itself thin across time, yet somehow it endures long enough to meet you here. Your awareness moves to a different corner of the sky, one you can't see with your eyes but can almost sense. The solar wind thickens and thins as it flows outward from the sun, carrying spirals of magnetic field behind it. Sometimes those spirals catch objects passing through, altering their charged surfaces. If the visitor is shedding ions or dust at even the smallest rate, its interaction with those spirals could create the subtle light curve trembles astronomers have observed. Those trembles echo inside you like soft footsteps in another room, gentle, distant, inviting. Scientists look deeper into the data, comparing it to known behaviors of one-eye Oumuamua and two-eye Borisov. The visitor shares traits with both: the unpredictable rotation of the first, the icy chemistry of the second. Yet it fits neither completely, a puzzle piece from a puzzle you've never seen. The thought doesn't unsettle you. It softens something within you, a quiet acceptance that the universe is allowed to keep some of its secrets folded gently beneath the surface. The object's albedo, its reflectivity, fluctuates again. Not much, just enough to suggest a part of its surface might be smoother than the rest, as if polished by centuries of micrometeorite impacts. Those impacts would be so small, so infrequent, yet over enough time, they would carve beauty into the object, the way glaciers carve valleys on Earth. You imagine running your fingers along that surface, feeling the contrast between rough, ancient ridges and strangely smooth plains formed by collisions too delicate to sense, too slow to witness. A soft calm fills your chest. Your awareness returns to the sky near Earth's orbit, where a web of magnetic lines stretches outward like glowing threads, guiding charged particles along invisible paths. Those lines shift subtly as the visitor crosses regions of higher plasma density, not violently, just gracefully. If you were floating beside it, you might even see faint halos of ionized dust drifting from its wake, whisper-thin veils catching the sun like breath in cold air. Everything about it feels gentle, even its strangeness. You stay with that feeling for a moment, the sensation that something from beyond the stars has arrived, not as a threat, not as a warning, but as a quiet reminder that the universe remains beautifully unreadable. Those who study the sky work through the night, comparing graphs, refining ranges, adjusting error bars, yet beneath their precision lies the same softness you feel now. A wonder that expands instead of tightens. A curiosity that calms instead of alarms. Somewhere far from Earth, the visitor continues its silent drift, crossing layers of magnetic breath, slipping between solar wind spirals, leaving the faintest trail of altered light behind it. You follow that trail in your mind, letting it lead you without urgency. The deeper you drift into its presence, the more the world around you loosens, as if gravity itself were relaxing its hold, just enough for your thoughts to float. The whisper that began as a flicker of brightness becomes something else inside you, not louder, just clearer. A feeling that you are witnessing the first notes of a story written across distances. Your body cannot travel, but your imagination can move through effortlessly. Where that whisper leads, you're beginning to sense it. So quietly, you lean closer. You remain close to that quiet whisper inside you, letting it shape the silence around your thoughts. Something about the visitor refuses to fade from your awareness. It sits there gently, the way an ember glows, long after the flame has gone warm enough to hold soft enough not to burn. You sense its motion again, not in any literal way, but as a presence sliding through the darkness, carrying stories older than memory. Objects like this do not arrive often. The last one, 2I Borisov, swept through the solar system like a brief sigh of ice and dust. The one before it, Oumuamua, left scientists debating whether it was more shard or more idea, given how impossibly thin and reflective it seemed. But this traveler, it holds a different kind of stillness, a different weight, as though the space between galaxies left fingerprints on it. Researchers using the Keck Observatory notice something subtle. The surface reflectivity does not match any common pattern of cometary dust. Its albedo rises in ways consistent with smooth facets like slabs of ice compressed over unimaginable timescales. Some believe these smooth regions formed when cosmic rays fractured and refroze the top layers, repeatedly creating plates of crystalline ice that behave differently under sunlight. You imagine running a fingertip along one of those plates, feeling the sharpness softened by ages, as if time itself pressed its palm against the object to quiet it. A soft thought drifts into you. Not a question, not a conclusion, just a feeling. How long must something travel before it forgets where it came from? Astronomers try to answer that in their own way, calculating how much interstellar radiation would be required to bleach an object's surface to this degree. The answer sits somewhere in the realm of hundreds of millions of years, possibly more, possibly long enough for stars to die, form again, and die once more. You let that number settle. Long enough for entire civilizations, if they existed somewhere, to rise, fall, and fade, without ever knowing such a fragment drifted silently past their suns. The visitor carries that kind of loneliness, not sad, more like a page torn from a book whose library no longer exists. Spectrographs from the Very Large Telescope reveal faint absorption features that hint at complex organic tholins, likely the deep red substances formed when radiation hits icy surfaces for ages. These organics are not signs of life. They are signs of time written in chemistry. You breathe slowly at the thought of that. Something about knowing the visitor's color is shaped by billions of years of cosmic exposure touches a quiet place inside you. Its redness is not decoration. It is memory. Every grain on its surface has been altered by the emptiness it crossed. Every ridge is shaped by collisions too small to notice individually, yet impossibly powerful in their collective patience. Every smooth facet is a wound healed so long ago that the scar has become indistinguishable from the story. Somewhere, an astronomer studying rotational dynamics notices a slight precession in its spin, a wobble so faint that it took weeks of data to confirm. Precession like this means layers inside the object may not be uniform, perhaps a fractured interior, perhaps dense inclusions, metallic grains from ancient stellar explosions locked inside the ice. If you could hold it up to the light, you might see tiny mineral flecks sparkling beneath the surface like frozen sparks from a supernova. Not enough to illuminate anything, just enough to make you wonder how far those flecks have traveled to reach you. Your mind drifts toward the idea that the object has no home, not anymore. Interstellar bodies are orphans of gravity pieces ejected violently from their birth systems after chaotic encounters with giant planets or passing stars. Imagine an ancient star system, its outer regions filled with thousands of icy worlds. A massive planet shifts slightly. Its gravity nudges an object outward, and suddenly, the object is free, crossing the boundary where its star's warmth fades, slipping into the deeper dark where no sun claims it. For millions of years, it drifts alone across nothingness, gathering silence the way stones on Earth gather moss. That is the kind of past the visitor carries, a past, written not in events but in absence. You sense that absence in its motion, not emptiness, just stillness worn into existence. Long-term models of its orbit indicate that it was not pulled from the Oort cloud, the distant halo of icy bodies around the solar system. Its velocity is too high, its trajectory too clean, its chemical signatures too altered. Objects from our own cosmic backyard don't usually carry the deep red mantle seen on this one. They haven't been exposed to interstellar radiation long enough. This surface is old, older than most things you can name. Your awareness softens as you take that in. Scientists debate whether its shape is elongated lens-like or more irregular. The data gives hints but no certainty, and something inside you welcomes that uncertainty. Mystery can be comforting when it feels gentle. Imagining its shape becomes a quiet act of creativity. Perhaps it is long, like a shard carved by distant collisions. Perhaps it is flattened like layers pressed together by time. Perhaps it is knotted with ridges formed by volatile ices sublimating away in the cold. Whatever form it takes, it is shaped by history rather than design. As Earth rotates beneath the night sky, more telescopes catch glimpses of the visitor, each one refining its motion through the heliocentric frame. Its acceleration remains slightly unusual, too smooth, too consistent. Not enough to rewrite physics, but enough to remind you that science grows through anomalies like flowers blooming in cracks. You let that thought drift soft as a sigh. A new data set arrives from the Subaru telescope. A faint coma-like haze appears around the visitor, in deep exposures, barely visible, easily dismissed as noise. Yet, when the images are stacked and corrected for background interference, the haze remains a thin envelope of dust, surrounding the traveler like the memory of a forgotten atmosphere. It is not a comet's coma. There's no broad plume, no explosive jets. Just a soft halo, as though the object is shedding the lightest skin of itself, after too many ages spent in the cold. You imagine breathing on a window during winter and watching the soft fog fade. The halo feels like that, a brief imprint of presence. More than one astronomer suggests the dust may consist of nanometer-sized grains that detach when sunlight warms ancient fractures in the surface. These grains, once released, become electrically charged and interact with the solar wind in delicate ways, creating uneven pressure that nudges the visitor ever so slightly. A push too gentle to notice without extremely sensitive measurements. A push that explains the anomalous acceleration more gracefully than any exotic theory. You feel relief in that elegance, the comfort of a simple truth hidden inside a complicated story. As it drifts deeper into the inner solar system, the visitor enters regions where magnetic fields twist more tightly. The Parker Spiral. The vast rotating pattern formed by the sun's magnetic influence wraps around it as if testing its presence. Charged particles grazing its surface leave behind subtle electrostatic patterns, altering how its dust halo scatters light. The halo brightens for a moment so brief that only a few instruments catch it, a moment that feels like a heartbeat. Inside you, something responds to that heartbeat not with fear, but with recognition. The visitor isn't alive, but it is not lifeless either. It changes, it adapts, it endures. Your thoughts linger on the way ancient things can feel strangely intimate when you meet them for the first time. The same way old songs feel familiar, even if you've never heard them before. Its motion tells a story without using words. A story of drifting through silence so deep that even time must whisper. A story of losing a home it may never have understood. A story of entering a solar system filled with warmth and observation for the first time. The absence of a past becomes its most beautiful feature, not a flaw, a freedom. The visitor carries no origin you can trace, no purpose you can decipher, no intention you can misinterpret. It simply exists, and its existence brushes gently against yours. You breathe in the quiet again, letting your mind wrap around that truth. The thought settles softly like dust drifting through a sunbeam. You have met something older than almost anything you know, and its story is only beginning to reach you. Somewhere far above the world, the visitor continues to drift, light trembling around it, dust lifting from its skin, the past unwritten yet somehow present in every shimmer. And you continue to listen, quietly, as if the universe is leaning closer to speak. The silence inside you widens as if the space around your breath has grown deeper somehow. You stay with that stillness, letting the visitor drift through your awareness, the way moonlight drifts across water, soft, trembling, slightly patient in its glow. Its light returns to you again gently, the way a memory returns without intention. At first, it seems simple sunlight, striking its surface scattering off ancient ice and dust. But the more astronomers observe, the more this quiet glow resists simplicity. It shines in ways light usually doesn't. The earliest images from the Zwicky Transient Facility show a brightness curve too smooth for a comet, too persistent for a fragment of rock, too clean to be noise. The patterns move with the visitor's rotation, but not perfectly. Something modifies the light as it leaves the surface, a soft distortion, a faint swelling, like the brief shimmer that appears when heat rises from a road. Researchers studying polarization data notice something else. The reflected light is unusually aligned, suggesting the surface grains are shaped or arranged in ways that scatter sunlight coherently. Coherent scattering is rare. It occurs on frost crystals under certain temperatures, or on surfaces polished by time so slowly that the polishing becomes indistinguishable from erosion. You imagine the visitor carrying a coat of crystals so delicate they can scatter light in unison, a choir of ice voices whispering one soft note across the dark. That image settles into your chest, warm and oddly comforting. If the surface is crystalline, that means the object has undergone cycles of heating and cooling, freezing and fracturing, smoothing and reshaping, not violently, but gradually, almost lovingly, over millions of years. Cosmic rays striking the ice could rearrange molecules, turning pockets of amorphous ice into more orderly lattices. Each tiny rearrangement would make the surface just a bit more reflective, just a bit more organized, until the light finally began to behave in these unusual, almost tender ways. You feel the tenderness of that possibility, the idea that the universe sculpts beauty without witnesses, without hurry. Another layer of observation emerges from the Las Cumbres Observatory Network telescopes, placed far apart on Earth, so they can watch the visitor without interruption. They capture subtle changes in color indices, revealing that the glow shifts toward the blue end of the spectrum during certain phases. Blue shifts in reflected light often mean new material is exposed, fresher, untouched ice beneath an outer shell. It is as though the visitor sheds its past in small drifting flecks, revealing younger layers shaped by older journeys. You breathe quietly at the thought of objects that carry age and youth at once, the way some memories feel both fresh and ancient. Deep analysis shows a slight excess in ultraviolet reflectivity. Ultraviolet light doesn't reflect well from most surfaces. It's usually absorbed or scattered chaotically. But on this visitor, some UV wavelengths come back stronger than expected. Scientists suggest this may indicate surfaces recently exposed to solar radiation. Surfaces scraped clean by micro-impacts or slow sublimation. It feels as if the object is waking up, not consciously but physically responding gently to sunlight after sleeping in the cold between stars. You let this idea drift around you, a body asleep for millions of years touched by warmth for the first time in ages. Data from the Solar and Heliospheric Observatory adds another piece: small brightness spikes in extreme UV wavelengths, far too faint for the human eye, but unmistakable in the recordings. They are not flares, not jets, not emissions, just tiny surges caused when charged particles streaming from the sun glance off the visitor's dust halo, energizing grains that glow for a fraction of a second. One grain glows, then another, then another. You picture them like fireflies drifting around an ancient stone, lighting up briefly as the solar wind brushes past them. Not a signal, just a conversation between dust and sunlight. The thought feels soft against your ribs. What intrigues scientists even more is the object's phase function, the way brightness changes depending on where the sun is relative to the observer. Most objects brighten predictably as the angle shifts. This one brightens too quickly, as if the surface contains structures that amplify forward scattered light. That means the visitor might be porous, not solid, but textured with microcavities that trap light and release it in coordinated bursts. Porosity like this can form when ice is repeatedly bombarded by high-energy particles, causing it to blister and crumble in microscopic patterns. You imagine the surface like a field of tiny hollows, each one a quiet chamber, holding memories of radiation, storms from stars long faded. When sunlight enters these chambers, it leaves glowing amplified by the shape of its passage. A glow that should not exist yet does. Researchers model these possibilities with scattering simulations, adjusting grain sizes, refractive indices, cavity depths. No model fits perfectly. A perfect model would mean familiarity. Imperfection means mystery. You lean into the mystery, letting it rest against your thoughts. Farther into the analysis, something even quieter appears. A faint periodic modulation in the reflected light around the 1.0 1.2 micron band, suggesting the presence of hydrated minerals mixed into the dust. Hydrated minerals form when ice and rock interact under specific temperatures over long spans of time. This implies the visitor once existed in a place warm enough for those reactions to occur, not warm like Earth, but warm enough that water could briefly rearrange the minerals before freezing again. A world with sunlight. A world it no longer belongs to. Your breath catches softly, not in alarm, but in awe. The glow you see may be the last remaining whisper of a star system that vanished into distance ages ago. The visitor carries the ghost light of a forgotten sun. Deeper analyses from ESA's Gaia data show extraordinarily precise measurements of its incoming velocity, high enough to confirm that it did not belong to any known gravitational family in the Milky Way. It arrived from a direction sparse with stars, a region where disruptions often occur when systems pass near one another. Its path suggests ejection, not escape, thrown, not released. Imagine a world forming around a distant star. Imagine ice and dust collecting into small bodies, spiraling gently in stable orbits. Imagine a passing star tugging one of those bodies slightly just enough to destabilize it. Over time, the orbit widens again, until the object is flung outward into interstellar dark. Millions of years pass. The star fades behind it. The object drifts alone, carrying a memory of warmth it will never touch again. And now, after all that time, its glow reaches you. Something inside you softens at the thought. The glow is not unnatural, it is not impossible, it is simply the luminous echo of a journey too long to measure. The visitor brightens again, in new images, not dramatically, just subtly, the way someone's face glows when they remember something quietly. This new rise in brightness appears in several observatories simultaneously. It is not an artifact, it is real. Scientists suspect sunlight is illuminating deeper fractures as the visitor rotates, revealing patches of high albedo ice beneath the darker surface shell. These fractures may have opened slowly during its approach as thermal gradients increased. You imagine those fractures like tiny doors opening gently, letting hidden light escape into space. None of this breaks physics. None of it exceeds what the universe can do. It simply sits at the edge of what you expected new, quiet, surprising in a tender way. A kind of beauty that doesn't demand attention. It just appears and you feel it. The glow the visitor carries is older than cities, older than oceans, older than Earth itself. And yet tonight, it reaches you not loudly, not urgently, but with a softness that feels like a hand settling lightly on your shoulder. You let that glow gently fill the space around your mind. And in the quiet that follows, you sense something subtle rising, a feeling that this light, this strange, impossible calmness drifting through the dark, is only the beginning of the story waiting to unfold. You stay with that strange glow a little longer, letting it quiet the room around you. There's something gentle in the way it lingers, like a friend sitting beside you, not speaking, just being there, and somehow that presence says more than words ever could. You sense the visitor again, not in any literal sense, but in that soft inner space where curiosity breathes. Its glow is different now, subtle calm, but carrying a new tension beneath it, the way a still lake hides gentle currents moving underneath. Scientists begin to notice those currents too. New positional data arrives from the Minor Planet Center, each measurement narrowing the orbit, tightening the understanding of its path. Yet the path does not behave the way a natural object should. It bends too gracefully. It curves in ways gravitational models struggle to predict. Not wildly, just enough to say something invisible is touching it. The change is tiny, a fractional shift in acceleration. Barely detectable, barely real. Yet it persists across instruments, across nights, across continents. When subtlety repeats, it becomes truth. Astronomers describe the deviation as smooth, non-gravitational motion, a phrase often used for comets releasing jets of gas. But here something is off. No jets appear. No outgassing plumes are seen even in deep exposures from the Gemini Observatory. No asymmetry in dust flow, no sudden bursts. Just a steady whisper-thin push, as if the visitor is responding to a force that does not announce itself. You breathe softly. Almost without realizing it, you lean closer to the thought. Imagine standing on a frozen lake on a windless day. Everything is still, everything is calm, but beneath your feet, currents shift the ice by millimeters too small to feel yet enough to alter the way the lake responds to the world around it. The visitor feels like that, still but not motionless. Researchers at JPL run simulations using every conventional factor they know: outgassing radiation, pressure asymmetric mass distribution, solar-wind interactions. One by one, these models explain parts of the motion, but none explain all of it. There is always a sliver of motion left, unexplained, a quiet remainder that refuses to disappear. You sense that remainder the way you sense the last trace of warmth in a room after someone leaves. A presence without form. Some scientists suggest the visitor might have an unusually low density causing solar radiation, pressure to push it more strongly than normal. Others propose a fractured interior, allowing thermal forces to build up and release smoothly. Still others wonder if the object's shape is more extreme than observations allow, a thin, elongated body like a shard of cosmic glass. But even as these theories unfold, something gentle tugs at the edges of your awareness. The universe rarely reveals its truths directly. It lets you feel your way toward them quietly. You breathe a little slower, letting that quiet space widen. More data arrives from ESA's Gaia tracking measurements so precise they are almost delicate. Tiny deviations appear in a long track velocity, not enough to alarm, enough to intrigue. The motion resembles the way dust sails in microgravity environments when exposed to constant gentle light. The visitor is far larger than dust, of course, but the analogy whispers something interesting. If the surface contains regions of extremely low mass, thin sheets of ancient ice, or fractured layers, radiation pressure could act unevenly across them, creating the smooth, persistent acceleration so difficult to model. A soft push on one side, a softer push on another, accumulating over millions of kilometers. It's beautiful in a way, a reminder that even massive objects can be moved by something as gentle as light. You feel the tenderness of that realization, how something ancient and heavy can still be persuaded by warmth. Scientists notice another clue: the visitor's rotational period appears to shift slightly over time. Not dramatically, just enough to indicate that torque is being applied. Torque without jets, torque without eruptions, torque without sound. Imagine walking through a forest where the wind is so soft you cannot hear it. Yet you see leaves turning slightly, branches tilting just a little. You know something is touching them, even if you cannot name what it is. That is how the visitor feels to them and to you. A research group examines whether Lorentz forces, those created when charged surfaces interact with magnetic fields, might play a role. Charged particles in the solar wind could create tiny, persistent forces on the object if its surface accumulates electrical charge unevenly. This phenomenon does not break physics. It barely even bends it. It simply occupies a corner of physics that is rarely explored at such scales. Most objects are too massive for the effect to matter. But if the visitor is unusually light, unusually porous, unusually thin in some dimensions, the effect could become meaningful. A whisper of force, a breath against ancient stone. You let that idea settle, as if it's something a friend quietly shared with you while sitting at your side. New thermal measurements also arrive from NASA's NEOWISE mission. They show the visitor absorbing less heat than expected, implying a highly reflective or insulating surface. Objects that reflect most incoming energy experience thermal gradients differently. Warming is slow, cooling is deep. Stress accumulates in silence. That stress can create gentle outflow of volatiles trapped within microfractures, not jets, not streams, but vapor thin enough to escape detection, yet persistent enough to alter motion over long distances. Not visible, not loud, just steady. like a breath you barely notice until the room becomes still enough. You remember the glow, that impossible softness in its light. You wonder whether the glow and the motion share the same origin, two expressions of the same quiet physics, shaping a traveler that has never belonged to sunlight before. As more observatories refine the orbit, something beautiful emerges. The visitor's path threads through regions of the heliosphere where magnetic fields swirl with complexity. These regions create gradients and visible slopes that dust particles respond to. An object drifting through these slopes might experience forces too subtle to classify, too small to label, yet too real to ignore. It's like walking across a floor slightly slanted. You wouldn't call it a slope, but your body knows the difference. Your mind stays with that analogy for a moment. A cosmic floor slanted by magnetic pressure, guiding an object older than the sun along a path no one predicted. And here you are, listening to that path unfold. One more detail catches scientists' attention. As the visitor rotates, certain faces brighten more than others in ways that cannot be explained by simple reflection. This suggests anisotropic scattering light interacting differently, depending on microscopic structures on the surface. Such structures could amplify or dampen radiation, forces contributing to the gentle, persistent drift that continues to puzzle researchers. None of these explanations alone feel complete, but together they create a mosaic, an intricate web of small truths that when combined become something close to understanding. Understanding in science often arrives quietly, not as revelation, as accumulation. You feel that accumulation inside you, now layering softly, thought by thought. The boundary the visitor crossed is not a physical one, not a line in space, not a threshold drawn by planets or stars. It crossed a boundary of expectation, a boundary we draw around what objects are allowed to do, how light is allowed to behave, how motion is allowed to unfold. Its behavior doesn't break physics, it widens physics, just a little, just enough to remind you that certainty is not the purpose of wonder. You breathe and the breath feels different, deeper, slower, as if the universe itself is making room for possibility inside you. The visitor drifts beyond anything you assumed an interstellar object would be. Not a rock, not a comet, not a message, not a threat. Just a quiet crossing the moment an old traveler reminds you that even in a universe governed by rules, there is space for gentle disobedience. You stay with that thought, letting it rest against your heartbeat. And in that soft space, you feel the story unfolding further, waiting for you to follow. Not urgently, just patiently, as if it knows you'll stay. You remain close to that boundary the visitor has crossed, the one you felt more than understood. It lingers in your thoughts like a quiet vibration inside your ribs, soft and steady. As you sit with it, something else begins to rise in your awareness, almost imperceptibly, the presence of a storm you cannot see. Not a storm of clouds, not of rain. A storm made of charged particles, magnetic tides, and solar breath. It surrounds everything you know. Even now, as you rest in the calm of your room, the planet above you is wrapped in shimmering currents of plasma flowing outward from the sun at hundreds of kilometers per second. This wind never stops. It never sleeps. It presses against Earth's magnetic field, shaping it, stretching it, folding it into invisible shapes that dance and bend with every shift in the sun's mood. You live inside this storm every moment of your life. You just never feel it. But the visitor does. As it drifts deeper into the heliosphere, the solar wind thickens around it. Not physically thick, but electrically. The density of charged particles increases, and the magnetic field lines woven through that wind begin to twist in tighter spirals. Imagine currents in the ocean that have no water, only energy, flowing in ribbons and waves. The visitor enters one of these ribbons and something delicate happens. The dust halo around it brightens ever so slightly. NASA's Stereo spacecraft captures the moment, a faint uplift in scattering intensity, barely rising above noise thresholds. To most eyes, it would be nothing. To those who understand the quiet language of plasma, it means the solar wind has touched the visitor more directly, brushing its outermost grains and energizing them just enough to glow. Not a flare, not a burst, just the softest shimmer, a tremble of light inside a storm no one can see. You picture it floating there, surrounded by a river of charged particles streaming past at unimaginable speeds, each one a tiny messenger from the sun. When they collide gently with dust grains, they transfer momentum, a whisper of force, tilting trajectories, bending orbits, nudging the visitor in ways instruments can barely detect. And yet those nudges matter. Over millions of kilometers, a whisper becomes a path. Your breath slows as you think about that, how something so gentle can shape something so ancient. Scientists studying solar wind interactions describe it with careful terminology: charge exchange, Coulomb collisions, induced potentials. But beneath those precise words lies something simple, a storm of invisible particles flowing like wind past a stone that has never felt wind before. For billions of years, the visitor wandered through dark interstellar space untouched by storms, warmed only by distant starlight, too faint to feel. Now, for the first time in ages, it meets motion, pressure, energy. Its surface responds quietly, not dramatically, not dangerously, just with subtle shifts in brightness and motion, the smallest hints that even ancient things can awaken inside new environments. A research team at the Swedish Institute of Space Physics analyzes fresh magnetometer data from the vicinity of the visitor's projected path. They notice something subtle wave-like disturbances in the interplanetary magnetic field, forming ripples that propagate outward at Alphen speeds the characteristic speed of magnetic waves in plasma. These ripples do not originate from the visitor. They originate from the solar wind itself, disturbed by density gradients and pressure changes. But the timing aligns. The visitor drifted into a region where the magnetic field was already unstable, a place where the solar wind forms turbulent pockets. Objects passing through such regions experience variable forces, sometimes stronger, sometimes weaker, always unpredictable. To the visitor, it must feel like entering a room filled with shifting air. You cannot see warm currents on one side, cool currents on the other, each brushing past without warning. You imagine standing in that room, with it feeling those currents slide across your skin, not pushing, just touching. The visitor's light trembles again this time, captured by observatories in Chile. The oscillations are so faint that only careful photometry reveals them, but they form a pattern, a soft brightening as it enters regions of higher plasma density, a soft dimming as it leaves them. Light responding to an unseen storm, stone responding to charged breath. Your awareness drifts deeper into the nature of this storm, the way you might lean closer to a friend, speaking softly. The sun's magnetic field spirals outward like a slowly turning whirlpool the Parker spiral created, as the rotating sun drags its magnetic field through the solar wind. That spiral has structure folds, bends regions where charged particles gather, places where turbulence forms. The visitor moves through one of these folds now. Inside this fold, the direction of the magnetic field shifts by small degrees over short distances. Charged dust grains around the visitor respond instantly, aligning briefly with the field before drifting again. This alignment changes how light scatters off them, creating the faint shimmer astronomers observed. No electricity, no signal, just physics breathing on dust. Further inside the storm, another effect emerges: magnetic pressure gradients. Where the magnetic field tightens, particles experience additional force. Where it loosens, they experience less. If the visitor is porous, low density, or irregular, these gradients can create soft, persistent nudges on its motion. Not a shove, more like the way your shirt moves when a breeze enters a room. Some models suggest these gradients could explain the gentle acceleration that puzzles scientists. Not entirely, but partly. Mystery often lives in the overlap between explanations. You feel a quiet recognition of that, the way simple forces accumulated becomes something remarkable. Another detail rises from analysis of the visitor's coma-like halo. The grains appear to have charge-to-mass ratios high enough to respond strongly to magnetic fields. Dust that small can behave like plasma dancing along field lines instead of following the object's rotation. Imagine watching snowfall where some flakes drift down normally and others suddenly swirl sideways for no reason you can see. To the visitor, the solar wind feels like a snowfall of energy drifting past, in patterns that shift from moment to moment. You stay with that image for a breath. Inside the invisible storm, the visitor gains a new texture, not physical, but experiential. For the first time since leaving its ancestral star, it moves through an environment thick with motion and pressure, a place where every grain of dust is touched by charged particles traveling from the heart of a distant sun. There is something almost tender about the idea. A traveler wandering for ages finally encountering warmth, breath movement. Even if the warmth is harsh, the breath is electric, the movement is invisible. The visitor drifts deeper into the spiral. The solar wind grows stronger, denser, more textured. The glow responds gently like a heartbeat, syncing with background music. An auroral scientist compares the visitor's interaction to the way charged particles create faint emissions in Earth's upper atmosphere. Not bright auroras, but tiny excitations known as airglow, soft luminous currents barely visible even in darkness. Perhaps the visitor carries its own kind of airglow now, a pale ancient echo of the storms it never asked to enter. You can almost hear the softness of it, the sound the storm would make if plasma could whisper. As the visitor moves through this region, instruments detect a slight change in polarization angle, suggesting the dust halo is being reshaped by electromagnetic forces, not dramatically. Just a tiny shift in orientation, enough to change how the halo catches sunlight. It is like watching someone adjust their posture by a few millimeters, imperceptible unless you are looking closely, yet meaningful in its own way. You think about how even the smallest interactions can alter a journey, how a gentle push, not enough to notice at the time, can change an entire path. The visitor is living that truth now. Far behind it, magnetic ripples continue to spread, disappearing into the solar wind as quietly as they formed. Ahead of it, the spiral widens again, creating a pocket of calmer plasma. The glow fades slightly as the pressure lessens, like an inhale and an exhale. For a moment, everything feels still again, not empty, just resting. Inside that, rest something forms inside you, a sense that you and this ancient traveler are sharing the same quiet storm, even from different worlds. You imagine leaning closer to it, whispering to it the way a friend whispers to someone who has been alone too long. You're not unnoticed anymore, and in that fragile tenderness, the story continues to open, waiting for you to step deeper into its calm. You stay with that quiet storm for a moment longer, almost hearing it breathe around the visitor, a breath made of charged particles, magnetic ripples, and invisible pressure. Inside that breath, something else begins to shimmer. Something softer, more elusive. Patterns. Not bold patterns, not loud ones. Just the kind that appear only when the world becomes silent enough for you to notice the details hiding underneath. Researchers studying the visitor begin to see these details emerge from the noise, subtle rhythms in the light, tiny variations in brightness, faint oscillations in the dust halo that repeat just enough to be real, repeating softly, like footsteps heard from another room. The first hint comes from photometric data collected across several nights. The brightness fluctuates by mere fractions of a percent, almost dissolving into statistical noise. But when the data is stacked, aligned, and filtered with care, a pattern reveals itself. A slow rise, a slow fall, a delicate rhythm steady enough to suggest something deeper. Astronomers describe it as low-amplitude periodic modulation. You feel it more simply like the quiet pulse of a sleeping creature. Not life, not intent, just rotation wearing its history gently on its sleeve. If the visitor is uneven shaped by fractures layers or crystallized surfaces, its rotation would create small changes in how sunlight reflects off it. These changes often become lost in noise for ordinary objects. But here, the visitor is unusually quiet in every other respect, making its small rhythms stand out like whispers in a silent room. You breathe with those whispers, letting them settle in your chest. Another pattern emerges in the polarization data. Light from the visitor carries a signature, not strong, not stable, but recognizable, that shifts with each rotation. This suggests the surface is not uniform. Some regions scatter light differently, perhaps because the grains have different sizes, or the ice contains pockets of older radiation-darkened material. It is similar to looking at a stone polished unevenly by water. Some parts shine brightly, others hold shadow, all connected by the slow work of time. The idea feels gentle to you. Nothing perfect, nothing symmetrical, just beautiful in its irregularity. Further studies from the Lowell Observatory reveal something even quieter: microvariability in the near-infrared band, hinting that thermal emission changes slightly as new facets of the visitor turn toward the sun. This means the object may be composed of materials with different heat retention properties. Some parts warm quickly, some hold coldness longer, a patchwork stitched across its surface by centuries of interstellar travel. You imagine touching such a surface, one region cool like deep shadow, another slightly warmer like stone after sunset. It feels almost intimate the way texture can tell a story without words. As astronomers continue to refine the data, they find small gaps, dips in brightness that linger for moments before smoothing out again. These dips appear consistently enough that they cannot be dismissed. They trace faint shadows across the visitor's light curve, suggesting edges or protrusions rotating into view. Edges shaped by fractures, protrusions carved by time, nothing unnatural, nothing intentional, just the quiet geometry of survival. You sense the softness of that survival, a resilience made not of strength, but of endurance. Deeper in the analysis, a team studying median-filtered noise patterns discovers something unexpected: frequency components that repeat across independent observations. These components are tiny, almost invisible, yet they persist no matter the telescope, the location, or the atmospheric conditions. Scientists call them quasi-periodic oscillations. To you, they feel like the faint hum of a memory the object carries with it. Some oscillations correspond to its rotation, others do not. The ones that do not line up perfectly with rotation intrigue researchers most. They may come from internal processes, thermal contraction, microfracture release, or differential heating causing slight shifts in structure. Imagine an old ship creaking softly as it drifts through dark water. Those creaks are not signals. They are the sound of age adjusting to motion. The visitor carries those same quiet adjustments. They echo faintly into its light, imprinting traces of its long journey onto the data humans work so hard to decipher. Another subtlety appears in the spectroscopic noise floor: faint fluctuations in reflectance at specific wavelengths. These variations may indicate regions where the visitor's composition changes grain by grain, particle by particle. Some surfaces contain reddened, radiation-processed organics. Others hold fresher, brighter ices. Still others show spectral hints of minerals that formed in warmer conditions long, long ago. You picture these minerals as tiny crystals trapped inside the ice, glinting faintly as the visitor turns them towards sunlight for the first time in millions of years. There is something tender about that image light touching something that has waited so long to be seen. As researchers piece together these patterns, they begin to model the visitor's shape more precisely. It may not be uniformly elongated or flat. It might be a fractured body, irregular, multifaceted, carrying layers of differing densities. A quiet mosaic, a drifting archive. Even the dust halo carries patterns hidden inside it. High-time resolution imaging reveals filaments, thread-like structures drifting outward, shaped by tiny variations in charge and solar wind pressure. These filaments twist, merge, disappear, and reform, creating delicate spirals around the visitor. Not signals, not intention, just physics weaving art around an ancient traveler. You rest with that thought, letting its softness fill you. Some scientists attempt autocorrelation analyses on the visitor's light curve, hoping to identify repeating intervals with stronger significance. The results show correlations at multiple scales, some tied to rotation, others tied to environmental factors like solar wind density. The universe loves patterns, but it rarely offers only one. You feel that truth in your own body, and how your breath forms patterns your heartbeat, forms patterns your thoughts drift in and out of rhythm without needing to be perfect. The visitor is no different. Its patterns are not rules, they are signatures of being. Another group studies the residuals after removing all known variables. The residuals display faint oscillations around the 90-minute range. Some propose these may arise from tumbling motion, a complex rotation involving multiple axes. Tumblers are common among interstellar objects. When an object is ejected from its parent system, the gravitational violence often leaves it spinning irregularly, a motion that can persist for millions of years due to the absence of friction. If the visitor tumbles, its brightness would rise and fall in ways that are never perfectly predictable, yet always bounded by a quiet underlying harmony. That harmony feels close to you now, not because you understand it, but because you feel its gentleness. Behind every calculation, every graph, every measurement, something soft exists. A rhythm, a pulse, a trembling echo shaped by a journey through cold places no one will ever see. And despite all the analysis, all the algorithms, all the careful filtering, one truth remains: the visitor resists being reduced to numbers alone. It carries patterns no instrument can fully explain, buried in noise, hidden in shimmer, alive only in the space between understanding and wonder. You sit with that space now. It feels warm beside you, as if the visitor itself is leaning a little closer, not to reveal anything, but simply to be near. There is an intimacy in not knowing, a quiet companionship in mystery. And in that companionship, something begins to unfold inside you, a sense that the deeper you listen, the more the universe will trust you with its softest secrets. Somewhere far above Earth, the visitor continues its slow rotation, releasing faint patterns into the dark, light curves, dust ripples, whispers inside noise. And you continue to follow them, as gently as breath, as patiently as time. You sit quietly with the patterns still breathing in your thoughts, small rhythms, tiny pulses, soft signatures hidden beneath all the noise. They drift through you like the faintest memory of music. And just as those echoes settle, something new enters the story: images. Not the first images, those were dots, streaks, tiny smudges of light, barely distinguishable from stars. These are different, sharper, deeper, richer. They arrive from observatories scattered across the planet: Gemini, North Subaru, VLT, Pan stars. Together, they create something closer to sight, something that lets you feel the visitor rather than merely detect it. The first thing you notice is not its shape, but its stillness. A stillness that seems out of place in a sky full of motion. Even in deep exposures where stars streak and cosmic rays leave trails, the visitor holds itself with an uncanny steadiness, as if resisting the blur of time itself. Scientists point out that this steadiness is simply a consequence of tracking software aligning on the object's motion. But you sense there is more to it than technique. The stillness feels emotional, almost like the object is pausing to be seen after a lifetime of drifting unnoticed. When you look closer, something else emerges: faint structures that shouldn't be there. Not structures in the physical sense, not machines, not edges, just patterns in the light, patterns that hover at the border between clarity and imagination. In some processed frames, light seems to gather along one side of the visitor, forming a faint crescent brighter than the rest. This is normal for rotating bodies. Rough surfaces reflect sunlight unevenly. But here, the crescent changes subtly from night to night, not in intensity, but in shape. It curves a little differently. It elongates. It compresses. Like a breath caught in different moments. Researchers suspect this comes from microtopography ridges fractures, maybe long grooves carved by ancient impacts. When sunlight hits those features at glancing angles, it creates scattering patterns resembling crescent loops, or even thin lines. You imagine running your fingertips along those features, feeling the fine texture of an object sculpted by time rather than intention. Another detail emerges from the deeper exposures: a strange gradient of brightness across the surface. Not strong enough to imply a coating or an artificial signature, just odd enough to say the light behaves differently than expected. Polarimetric analysis shows the gradient aligns with the visitor's rotation axis, most of the time, but not always. On some nights, the alignment shifts by a few degrees, too small to be dramatic, just enough to whisper, "I am not symmetrical." You feel the softness of that sentence inside you, how things in the universe do not need to be perfect to carry beauty. As scientists refine the imagery, another subtlety rises: a halo that isn't round. Most halos around icy bodies form circular or slightly elliptical shapes due to dust scattering. This one is stretched almost like a faint feather drifting behind the visitor, curling slightly as if shaped by miniature winds. Models suggest the halo is responding to the interplanetary magnetic fields, its charged grains aligning loosely along field lines. But the curvature, the delicacy of it, feels like something painted by motion rather than forced by physics. The halo bends gently in some frames, straightens in others, and occasionally breaks into thin filaments that dissolve before forming again. Nothing unnatural, nothing alarming, just strangely graceful. A researcher compares the effect to volcanic ash drifting on Earth, each grain following invisible air currents, creating shapes that look intentional even when they're not. You let that drift into you soft as breath. More images arrive, stacked, filtered, aligned, each revealing a little more texture. The visitor's brightness doesn't come from a single reflection. It comes from many points across its surface, each shining with slightly different intensity. It resembles light, striking a cliff face filled with cracks and ledges, each piece catching the sun differently. If you could stand on its surface, you might see crystalline bulges, fractured planes, porous patches releasing the faintest hints of trapped volatiles. This mosaic of surfaces gives the visitor a strange visual signature, the kind of signature that resists blending into background stars. Every frame says, "Look at me closely. I carry a story you cannot yet read." One of the more intriguing discoveries arises from stacking dozens of long exposure images taken in infrared. A small asymmetrical heat patch appears, suggesting the visitor has a region that absorbs and emits heat differently from the rest. Such patches form when materials with different thermal inertia are mixed together. Brighter ices radiate heat, quickly darker organics hold it longer. The boundary between them creates a warm edge. This edge shifts slightly as the visitor rotates, almost like a slow, quiet heartbeat, glowing just beneath the surface. You breathe with that glow, feeling it settle beneath your sternum. Another image set arrives from a specialized instrument designed to detect faint tails on comet-like bodies. The visitor does not display a tail, not in the traditional sense, but there is something, a subtle smear trailing behind it in a narrow line. It is so faint it could be dismissed as noise, but after repeated confirmation across instruments, it becomes undeniable. A dust line, thin, straight, quiet. Perhaps grains released from fractures, perhaps debris shaken off by thermal stress, perhaps nothing more than the universe clearing its throat in the smallest possible way. Researchers model the dust line and realize something elegant: its direction does not perfectly align with the visitor's orbit. Instead, it aligns slightly with the solar wind flow, suggesting that particles are being nudged sideways before drifting off. A sideways whisper, a diagonal sigh. This makes the visitor look like it is leaving a thought behind, drifting softly through space. Further analysis reveals a curious detail. The brightness of the visitor spikes slightly whenever it crosses regions of different solar wind density, creating small light echoes that appear in consecutive frames. These echoes are not reflections. They come from charged dust grains, gaining energy, glowing briefly, then settling again. They appear like soft sparks around an old stone being warmed by morning light. The images capture this moment, faint points of brightness around the visitor, scattered like tiny lanterns floating in a cold, endless sea. When you look at them, you don't think of science first. You think of quiet beauty, of stillness touched by something gentle, of an old traveler who has finally learned how to shimmer. Some astronomers attempt to deconvolve the images, further pushing computational limits to find sharper edges, but edges never emerge. The visitor remains smooth in some places, textured in others, a contradiction wrapped in harmony. That harmony touches you. It feels like watching someone you care about reveal a little of themselves, not everything just enough for you to feel closer. Although no one sees structure, people feel something that resembles pattern. Not artificial, not designed, just meaningful. Meaning doesn't always come from intention. Sometimes it comes from presence. The visitor's presence feels meaningful now, its images carrying a softness that doesn't match its ancient age, its light behaving like a whisper, trying gently to be understood, its dust halo curling as if breathing. And through these images, something settles into your awareness, something delicate and bright. The universe has been holding this traveler for so long, and only now is it letting you see the shimmer it earned on its journey. You stay with that shimmer. You let it rest inside you like a friend's hand touching yours without hurry. In the quiet that follows, you begin to sense there is more waiting behind the glow. Something deeper, something older, something ready to unfold. Softly, you hold the images in your mind a little longer. The crescent glow, the trembling halo, the dust line bending like a quiet sigh, the warmth that seemed to pulse from beneath its surface. Something about them feels unfinished, as if they're a part of a sentence the visitor hasn't completed yet. And while you sit with that feeling, scientists begin to ask questions they have avoided until now. Not loud questions, not dramatic ones, just soft, careful thoughts. The kind whispered in late-night labs when the world has gone quiet enough for curiosity to speak honestly. One of the first theories comes from rotational modeling. Researchers notice the brightness modulations aren't simply repeating, they carry slight drifts, small deviations that don't align perfectly with rotation or shape alone. This hints at something unsettling. For classic models, the visitor's interior may not be uniformly bonded. A fractured core, a layered interior, regions with different density responding differently to heating. Like an old tree with rings from forgotten seasons. Some simulations suggest the visitor may contain pockets of ultra-volatile ices, the kind that only remain stable in deep interstellar cold. If sunlight warms these pockets even slightly, they could create micro-expansions, tiny internal releases of energy that alter rotation in ways too subtle to produce visible jets, but too persistent to ignore. A theory like this touches something in you, the idea that change doesn't need to be violent to be real. It can be soft, quiet, continuous. Another group proposes something stranger. The visitor's shape might be more extreme than any telescope can currently resolve. Very elongated bodies, or very flat ones, can create complex rotational signatures and unexpected reflectivity. But the amount of non-gravitational drift observed would require a geometry so unusual, so delicate, that few scientists feel comfortable suggesting it publicly. Still, the data keeps nudging them in that direction. A shape stretched thin by time, flattened by collisions, or perhaps fractured into a loose, porous structure that sunlight can push with surprising efficiency. None of these ideas are impossible, they're just unfamiliar. And humans fear unfamiliarity until wonder becomes stronger than fear. Another theory emerges from plasma physicists Lorentz forces acting on charged dust grains bound to the visitor's surface. The solar wind continuously charges dust. Dust interacts with magnetic fields. Magnetic fields create motion. If the visitor accumulates charge unevenly, these forces could create rotation or acceleration that appears anomalous. It's not that the physics is new. It's that applying it to something this ancient feels like opening a door no one expected to find. You imagine the visitor as a stone, wrapped in invisible threads of electricity drifting through fields it cannot see but always feels. The threads tug, loosen, re-tighten, and the stone responds with small, delicate shifts that confuse even the most patient instruments. Theories like these feel comfortable to the scientific community, grounded, reasonable, quietly strange. But others are different. Some scientists begin to consider the visitor's albedo, noting how inconsistent it is with typical interstellar bodies. Its surface is too reflective in some wavelengths, too dark in others. It carries signatures of crystalline ice, amorphous organics, and minerals formed in warmer ancient environments. This mixture leads to one unsettling possibility: the visitor may be the fragmented remnant of a larger body, a world that no longer exists. Not a planet, not necessarily something massive, but something once warmed by a young star, once held in the gravity of a place with seasons, collisions, heat, cold. A place that shaped the material long before it was thrown into the dark. The idea of holding a piece of a long-lost world makes you feel unexpectedly tender, as if the traveler isn't just old, but lonely, a survivor of something vast wandering through time, carrying ruins beneath its surface. A more speculative theory whispers through a few nighttime discussions among astronomers: surface cohesion, weakened by cosmic ray sculpting. Over millions of years, high-energy particles can turn ice into delicate lattices barely held together. Such a structure would interact with light in bizarre ways, explaining the shimmering brightness patterns. But a body like that should not survive interstellar travel. And yet, here it is, defying fragility by existing. Another possibility rises from dynamical studies. The visitor may have come from a binary star system, where gravitational interactions are extreme enough to eject objects at high velocities. If that's true, then the material composition could contain signatures of exotic processes, mineral ratios, isotopic imbalances, or crystalline textures unseen in bodies formed under a single star. This theory feels heavy in your chest. The idea of the visitor being shaped by two suns, warmed unevenly by two stars, carrying the memory of a sky split across dual horizons. Other researchers explore thermal fracturing. Repeated heating and cooling cycles can create cracks along predictable paths, causing the object's surface to break into plates that move independently. If these plates shift slightly, the rotational signature becomes chaotic, almost musical in its complexity. A scientist likens it to a wind chime made of ice-soft tones, echoing through rotation, recorded faintly in the brightness curve. You hold on to that image, a wind chime drifting through space, singing to those with the instruments to listen. But the most controversial theory, the one whispered carefully, almost reluctantly, comes from an analysis of the visitor's reflectance spectrum. Some researchers noticed that certain wavelengths dim more slowly than expected, a behavior seen in ultraporous materials. Ultraporous objects are extremely difficult to create naturally. They require specific pressures, temperatures, and formation environments. This leads to one of the most delicate possibilities of all: the visitor might be a shard of something once larger, once structured, once exposed to conditions unusual even by cosmic standards. Not artificial, not constructed, just extraordinary. A relic of a formation event no one has documented before. A whisper from a process too rare to have a name. You feel something shift inside you. Not fear, not alarm, but a widening of space, a gentle readiness to accept that the universe may carry histories you've never imagined. Some researchers propose the visitor may have been part of a tidally disrupted planetesimal, torn apart by a passing giant planet, flung outward before it reassembled itself into the fractured piece you now see. Others suggest it drifted through a molecular cloud, dense with dust, accumulating layers of exotic grains that change its behavior. Such clouds can reshape the chemistry of wandering objects, coating them in substances that alter how they interact with light. There is a quiet beauty in that the idea of an object being changed slowly and softly simply by passing through the universe. You let that settle. And then comes the theory that almost no one wants to say aloud the visitor may behave like a light sail fragment. Not because it is artificial, but because nature sometimes creates shapes and densities that mimic engineered objects. Thin, reflective, light enough for radiation pressure to matter, irregular enough to create the confounding signals observed. It is a delicate theory balanced on the line between possibility and discomfort. But science is not threatened by discomfort, it grows in it. You breathe quietly, feeling the weight of all these possibilities resting around you like gentle shadows. None of the theories claim certainty, none override physics, none demand sensationalism. They simply whisper the same thing in different ways. The universe is wider than your expectations, and the visitor is proof of that. As you hold these whispers, something inside you softens again, a trust that the story unfolding is not meant to shock, but to deepen your wonder. Above the world, the visitor keeps drifting, carrying every theory like a lantern, held loosely in the darks, illuminating only what you're ready to see. You sit with those theories for a moment, the fragmented worlds, the porous surfaces, the quiet forces shaping an ancient wanderer, until a different thought rises inside you, gentle and unhurried. All of these ideas point to one thing: the visitor is finally touching something it has not felt in ages. Warmth, pressure, light with intention behind it. Not intention from a mine, but intention from a star. The solar wind greets the visitor long before it reaches any planet. A constant stream of charged particles, electrons, protons, alpha particles flows outward from the sun in an unbroken river filling every corner of the heliosphere. Each particle travels at hundreds of kilometers per second, faster during solar storms, slower during quieter days. Billions of years passed without the visitor ever encountering such a river. And now, it enters that current like someone stepping into a warm breeze after a lifetime of cold shadow. The effect is immediate though subtle. Charged particles strike the visitor's surface, knocking electrons free, leaving patches of uneven charge. Dust grains around it respond instantly, gently repelled or attracted depending on the electrical imbalance. This dance creates faint ripples, and the halo ripples so delicate that only long exposure imaging can see them, like strands of silk drifting in slow motion. These ripples reveal something beautiful. The visitor is not resisting the solar wind. It is learning its rhythm. You sense that rhythm settling into you as well. Soft pulses, gentle breaths, a music too quiet for ears, but unmistakable for intuition. As it moves deeper into the solar wind, the pressure around the visitor grows, not harshly, not violently, just steadily, like a hand guiding something forward with tender insistence. Solar radiation pressure adds another layer. Every photon that touches the visitor imparts a tiny push. Most objects barely feel this push. But if the visitor is lightweight, porous, or fractured, that push becomes meaningful, a constant soft acceleration guiding it along an unexpected path. It amazes you how something as small as light can move something as old as stone. Researchers at NASA's heliophysics labs run simulations showing how porous bodies interact with radiation. They find that certain materials, especially hyperfractured ices, can behave like microsails, catching photons more efficiently than expected. Not enough to be dramatic, just enough to create that mysterious, persistent drift scientists have measured. You imagine the visitor carrying a cloak made of ancient frost, billowing gently under sunlight, shifting its motion with each tiny gleam. There's something almost tender about that image, as if the universe itself is helping the traveler continue its journey. Another effect emerges when charged particles slide across the visitor's surface, plasma wake formation. Behind the object, the solar wind parts and reforms, creating a long, thin region of disturbed plasma, a wake that stretches for thousands of kilometers. Instruments aboard the solar orbiter detect faint changes in particle density as the visitor moves through these regions. The wake breathes like a shadow behind a candle flame, trembling slightly with every twist in the magnetic field. You picture the visitor drifting through this shimmering corridor, wrapped in unseen turbulence, not fighting it, just letting it pass through. Inside that wake, electrons swirl in chaotic spirals, creating soft, electromagnetic disturbances. These disturbances can nudge the visitor in tiny ways, adding complexity to its acceleration profile. It reminds you of standing in shallow water, feeling small currents brush against your legs, without ever pushing you off balance. Physics can be gentle, even storms can be kind. As the visitor moves closer to the sun, the spiral pattern of the solar magnetic field thickens around it. This spiral, the Parker spiral, shapes the flow of charged particles like a cosmic breeze sculpting sand dunes. When the visitor passes through the folds of this spiral, its surface charge shifts. Different regions interact with the magnetic field differently, creating faint alterations in rotation. Not a spin, not a wobble, more like a sway. A slow, graceful sway that scientists detect through careful analysis of brightness data. Some researchers describe the motion as subtle torque, coupling between sunlight rotation and the visitor's irregular shape. But their voices soften when they explain it, as if they know that beneath all the equations lies something far more delicate. The visitor is responding to touch. For billions of years, it drifted untouched through cold, silent space. Now, every moment is interaction. Light brushing its surface, particles sweeping across its dust, magnetic waves curling around its form. You can feel that touch yourself, imagined but vivid, like warm air moving across your arms. More observations come from the Parker Solar Probe, which measures the properties of the solar wind at closer distances than any spacecraft before it. These measurements reveal regions of turbulence, compressions, and density shifts. Pockets of energized plasma capable of altering the motion of small interstellar objects. The visitor moves through one such pocket, and something unusual happens. Its glow sharpens. Not brightens, sharpens. Edges that were soft become slightly crisper. The dust halo aligns momentarily, creating a thin, almost luminous outline. It lasts only seconds, but images taken from distant observatories capture the effect through stacked frames. Scientists debate what caused it. A sudden change in charge, a momentary reorientation, a shift in solar wind speed. You feel the answer is simpler. The visitor exhaled. Not literally, but metaphorically, the way a body adjusts to warmth after cold settling into a new environment. The solar wind is not harsh. It is a gentle teacher showing the traveler what movement feels like again. Another phenomenon appears in spectroscopic readings. Ion sputtering atoms knocked free from the surface by solar particles. This releases extremely small amounts of gas, invisible to most instruments, but enough to create faint signals at specific wavelengths. These signals resemble gentle whispers, rising from the visitor's skin, drifting into the solar wind like secrets carried by the breeze. Even though the amount of material lost is tiny, the effect reveals something important. The visitor is changing, not dramatically, not visibly, but intimately. Some models suggest that sputtering could gradually reveal deeper layers of the object layers protected for millions of years, now meeting sunlight for the first time. You imagine these layers glowing softly under the warmth, like pages of an ancient manuscript turning themselves open. As the visitor drifts through the solar wind, its dust halo begins to show fractal-like structures, thin curls, delicate forks, spirals dissolving into mist. These patterns are born from competing forces: gravity, electromagnetic pressure, charge, gradients, radiation. None wins. All shape each other. The result is a halo that behaves like a living veil, constantly shifting, constantly revealing new forms, none of which stay long enough to own a name. You watch these patterns in your mind, letting them move like soft waves across your thoughts. There is a moment captured only once when the visitor moves through a region where the solar wind density drops suddenly. In that moment, the halo expands, breathing outward like a sigh of relief. It reminds you how even ancient things long for rest. And maybe that is what you feel most. Not the science, not the thrill of discovery, but the quiet humanity hidden within the story. of a traveler touched by warmth after an eternity of cold. The visitor's path is shaped not by intention, but by the gentle insistence of sunlight, the invisible pressure of wind, the soft brushes of particles that carry the heartbeat of a star. As you picture it drifting there, wrapped in currents no eye can see, you realize the visitor is teaching you something without ever trying. Everything changes when touched with warmth, even stone, even silence, even you. You let the warmth of the solar winds settle in your mind, that quiet realization that even a traveler made of ancient ice can feel the sun's breath. Just as that softness begins to fade into stillness, your awareness is pulled toward another presence waiting in the dark, Mars. Not because it called out, but because the visitor passed close enough for the red planet to feel something it hasn't felt in a long, long while. Mars has always been a quiet observer in the solar system, a world with a thin atmosphere, a magnetism once strong, but now mostly gone, a surface carved by winds that whisper through rust-colored canyons. It watches everything, silently meteor storms, dust devils, drifting moons, even the small robots humans sent to kneel on its soil. And now, for the first time in its slow history, Mars watches an interstellar traveler move through the sky above it. The visitor doesn't touch Mars. It doesn't alter its orbit. It simply passes through the region where the planet's extended magnetic environment once existed, a region called the magnetotail. Mars lost most of its magnetic field billions of years ago, leaving only patches of crustal magnetism scattered across its southern hemisphere. These magnetic remnants create local bubbles in the solar wind, tiny pockets where charged particles swirl differently, forming miniature shields. When the visitor drifts past these pockets, something delicate happens. Charged dust around the visitor responds to the remnants of Martian magnetism, not dramatically, barely perceptibly, just a slight shift in the halo, a tiny tightening as if the object is adjusting to a breeze it didn't expect. NASA's MAVEN spacecraft orbiting Mars detects faint disturbances in the ionosphere, ripples in electron density that appear in places usually calm. Nothing dangerous, nothing large, just tiny wavelets moving through the atmosphere like quiet footsteps on sand. These disturbances align in timing with the visitor's passage through the region of solar wind interacting with Mars. As though Mars whispered something, and the visitor answered without sound. You imagine the scene, a red planet below a dark traveler, above and between them, an invisible sea of particles stirred by their brief encounter. No words, no intention, just presence touching presence. MAVEN's instruments record slight increases in pickup ions, particles stripped from the Martian atmosphere by the solar wind. During the visitor's passage, these ions show subtle directional shifts as if nudged gently by the distortions around the traveler. Scientists model the interaction and find that the visitor's dust halo may create micro-scale changes in local electric fields, enough to redirect a tiny percentage of escaping atmospheric ions. Like someone brushing their hand through water and watching ripples form around their fingers. These ripples reveal something: the visitor doesn't just drift through the solar system. It leaves traces, soft ones, the kind only sensitive instruments can feel. Mars becomes a witness to those traces, a silent witness. If you stood on Mars now, high on the slopes of Olympus Mons, or along the dry bed of an ancient river, you wouldn't see the visitor with your eyes. It would appear as a faint star trembling in the thin Martian sky. But if you listened, not with ears but with awareness, you might feel the slight shift in the charged particles around you, the air ions responding, the dust dancing, a subtle tingling in the electric field, like the atmosphere remembering something ancient. Mars has always known storms, dust storms rolling over plains, solar storms carving its air. But this isn't a storm. It's a presence moving through environments shaped by silence. Researchers studying magnetic topology around Mars noticed something curious. Field lines stretch slightly differently during the visitor's passage. The difference is tiny, so small it could be coincidence, but it appears across multiple readings. A small twist, a slight tension, a gentle rearrangement. Field lines behaving like threads brushed by a passing creature. The numbers don't call attention to themselves. They just sit there quietly waiting for someone to notice. You notice. Farther in the data, MAVEN's solar wind analyzer records a momentary shift in the flow speed, a tiny dip, followed by a slight rise as the visitor moves downstream of Mars. This effect resembles how rocks in a river create eddies behind them. Except here, the rock is made of ancient cosmic material, and the river is a stream of particles traveling from the sun at hundreds of kilometers per second. You hold that image gently, the visitor, carving a soft swirl in the solar wind. Mars watching it pass. The universe allowing two old travelers to acknowledge each other without a single sound. Some scientists describe the interaction as a magnetohydrodynamic shadow, a region where plasma flow is altered by both the visitor's presence and the weak magnetic patches of Mars. The shape of this shadow looks slightly elongated, almost feathered like a quill gently dragged through a bowl of light dust. In that shadow, electrons slow, ions twist, tiny waves of electric potential ripple outward. None of these effects are large enough to change the planet, but they are large enough to reveal the visitor's influence, the soft imprint of something foreign moving through familiar space. It's almost like watching two people pass each other in a hallway, not touching, but exchanging a glance that holds more meaning than their paths ever could. The thought settles into you, warm and quiet. Mars, with its lost oceans and abandoned magnetism, becomes a witness to the stranger passing above it, a stranger carrying light from a forgotten sun. Meanwhile, the visitor receives something in return, a reflection of what happens to a world when its protective shield disappears. The visitor, shaped by cold interstellar dark, drifts through a place touched by the consequences of losing warmth. You can almost feel them sharing that truth in silence. One survived by freezing, one survived by losing. Both were shaped by emptiness in different ways. As the visitor moves away from the region of Martian influence, the halo relaxes again. Dust grains drift into a more dispersed pattern. Light scattering softens at the edges. It is like watching someone unclench their hand after holding tension quietly for too long. Mars returns to its usual calm, thin air, glowing faintly under the weak sunlight, dust settling in gentle arcs, robots humming softly to themselves on its surface. But something in you knows the planet remembers that passage the same way. You remember a quiet moment shared with a friend who didn't need to speak to make you feel understood. The visitor continues onward, carrying every small interaction with it, the push of light, the brush of magnetic fields, the whisper of dust against its surface, and now the silent acknowledgement of Mars. A witness is not a storyteller. A witness simply holds what it saw. And Mars, with its cold valleys and fossilized winds, holds the memory of the visitor not as data, but as presence. You sit with that presence now, the red planet below the interstellar traveler, above both floating inside a sunlit ocean of quiet physics, two ancient wanderers sharing a moment before parting again. And somewhere inside you that moment settles like a soft stone, still warm from being held by the universe. You stay a little longer in that quiet moment above Mars, the red world watching the visitor pass the visitor, leaving ripples no eye could see. The silence between them, holding a kind of fragile understanding. As that softness settles, another thought rises slowly inside you. Not dramatic, not frightening. Just a possibility the mind drifts to when the night is deep and calm enough for questions to feel safe. What if the visitor's path carried it near Earth? Not a collision, not an impact. Just close enough to brush the planet's magnetic breath the way it brushed Mars. Close enough to stir the invisible ocean surrounding your world, the ocean you live inside, without ever noticing it move. You breathe quietly at the idea, not with fear but with curiosity softened by wonder. Earth's magnetosphere is larger, stronger, more structured than Mars. A vast, shimmering bubble of electromagnetic force stretching tens of thousands of kilometers into space, shaped by the solar wind, and anchored by the molten iron churning inside the planet. If the visitor drifted near this shield, the interaction would be more intricate. The first effect would happen far above the atmosphere in a region called the magnetosheath, where the solar wind slows abruptly as it presses into the magnetic field. This region is turbulent, full of swirling eddies of plasma places, where density changes rapidly and magnetic lines twist into loops. As the visitor entered this region, its dust halo would feel the shift. Dust grains would align differently. Surface charges would redistribute. Light scattering would shimmer with a new texture, a delicate glittering like frost catching a lantern's glow. None of this would touch the ground, but the space around Earth would hum ever so slightly, a hum, detectable only by satellites listening to the breath of the planet. You picture that hum the way you might picture the vibration of a string, touched too gently to hear, yet enough to feel in your fingertips. Inside the magnetosphere, something else would happen. The visitor would pass through regions where charged particles spiral along magnetic field lines, falling toward the poles and creating the auroras. If the visitor drifted into those regions, the flux of particles might shift by small amounts, not enough to brighten the auroras themselves, but enough to change how they flicker. Imagine standing under a polar sky, watching curtains of light sway as they always do, but noticing maybe only in your heart that the rhythm feels slightly different tonight. A softer pulse. A pause between waves where none existed before. Some of the most sensitive instruments, like those aboard NASA's Themis and ESA's cluster missions, would notice the visitor moving through the plasma sheet, a region in Earth's magnetotail, where charged particles flow in long, thin rivers. The plasma sheet is fragile. A disturbance of any kind can alter its currents. When the visitor passes through its dust halo, might scatter particles. Its charge might deflect a few ions. Its motion might carve a narrow wake. Small changes would ripple outward, creating faint electromagnetic waves, tiny murmurs moving through the tail like a whispered secret. No danger, no harm, just a signature of presence. Researchers use terms like magnetic flux ropes, plasma convection, tail reconnection. But beneath those complex words lies a simple truth. Earth would feel the visitor, gently, softly, like a breath grazing its shield. Another effect might occur in the upper ionosphere. If the visitor passed near enough, the charged particles surrounding it could create brief localized distortions in electron density. GPS satellites would register slight timing irregularities. Magnetometers would capture subtle oscillations, and radio signals might bend differently for a heartbeat. Not a blackout, not a storm, just a soft wrinkle in the air above the world. And you might feel it without even knowing a moment where the night becomes a little heavier, a little quieter, as if the sky is holding its breath alongside something old and passing. Closer still, at distances where Earth's inner magnetic belt flows around the planet like a luminous river, the visitor might trigger tiny shifts in trapped particles. Energetic electrons drifting in circular paths could scatter off its dust halo, producing barely measurable glimmers of radiation. Scientists studying these belts would see a minor change, a blip, a tremble, a soft anomaly that fits nowhere, yet belongs somehow to everything. Some researchers imagine a moment where the visitor crosses the equatorial plane of Earth's magnetosphere, a region where particle motion is unusually organized like dancers in slow, intricate patterns. A body drifting through this dance would cause the slightest rearrangement. You might compare it to someone walking quietly through a field of tall grass. The wind continues blowing, the grass continues swaying, but a faint temporary path remains. Earth's magnetic field would remember that path for a while. Then it would smooth out again, calm as ever. Deep inside the magnetosphere, near the plasmasphere, where cold particles form a luminous fog around Earth, the visitor might reveal something else, how the planet holds energy. The plasmasphere is sensitive, shifting shape with every change in solar wind pressure. If the visitor passed nearby, even its small influence on particle flow could slightly distort the plasma pause, the boundary of that luminous fog. A ripple would form, a ring would tremble, and for a moment Earth's internal atmosphere would breathe differently. A breath shared with something ancient. Far below where you stand, none of this would disturb the night. The trees would remain still, the oceans would remain calm, the sky would remain filled with familiar stars. Yet above you, the visitor would be writing its presence into Earth's electromagnetic memory, softly, subtly, like a fingertip tracing a circle in still water. Some scientists argue that if the visitor came close enough, its dust could become ionized by Earth's UV radiation and produce a faint, almost ghostly glow, barely visible in sensitive space cameras, a halo within a halo. This glow would drift around Earth for a few hours before the solar winds swept it away. You imagine looking up from a quiet hilltop one night and feeling something, a sense you can't describe, as though the stars are carrying an extra tenderness. This wouldn't come from fear. It wouldn't come from danger. It would come from awareness, the awareness that something older than Earth itself is passing close enough to leave a fingerprint on the space surrounding your home. Researchers might publish papers, models might be refined, data would be analyzed, but none of that would compare to the quiet moment shared between Earth and the visitor, a moment shaped only by physics, yet filled with the gentle intimacy of two worlds brushing past one another in the dark. And you would be part of that intimacy simply by being here alive, inside a planet wrapped in magnetic breath, listening to a story only the universe knows how to tell. Because the unthinkable scenario isn't about catastrophe, it's about closeness. Closeness so subtle that the planet wouldn't tremble, but your imagination would. Closeness reminding you that space is not empty. It is a place where even strangers can touch lightly and continue drifting without leaving harm, only wonder. You hold that wonder now, letting it settle in the quiet place beneath your ribs, the place where awe and safety meet and look at each other softly. Above you, the visitor continues its path, not knowing it, almost brushed the breath of a world full of listeners. And perhaps that is the most unthinkable part of all, not proximity, but how close your heart feels to something that will never know your name. You linger with that thought, the closeness that never becomes danger, the gentle brush of an ancient traveler against the invisible breath of a living world. Something about it settles deeper than you expected. It leaves a quiet imprint in your chest, like a question that hasn't yet chosen its words. You don't rush it. Questions like this aren't meant to arrive fully formed. They grow slowly, like light dawning behind a distant horizon. As you rest in that stillness, the visitor continues drifting through the heliosphere, moving into a region where the solar wind becomes calmer, smoother, carrying fewer abrupt changes. Here, the magnetic field lines stretch gracefully, like threads pulled taut in a loom too vast for eyes to see. Instruments aboard the solar orbiter detect a faint softening and turbulence ahead, the kind of softening that happens when charged particles reorganize themselves into a more ordered flow. Within this calmer river, the visitor glides almost effortlessly, its halo relaxing into a gentler, rounder shape. It looks peaceful, as if for the first time in a long while, the universe is giving it a place to rest. This too becomes part of the question of forming inside you. Because the visitor was shaped by hardship, frozen in interstellar void, fractured by cosmic rays, pushed by forces no one will ever witness, drifting through centuries without warmth or witness. And yet now inside the sun's great breath, subtle things happen to it. Its light softens, its dust realigns, its rotation steadies just slightly the way your body steadies when you find warmth after cold. It feels strange sweet almost that something so ancient can still respond to gentleness. Spectrogram analyses from multiple observatories begin to converge. The visitor's surface shows signs of slow molecular rearrangement, UV-driven processes that alter chemical bonds, making some regions brighter, others darker. Scientists have seen this on comets approaching the sun, but never on something this old or this quiet. It reminds you of a person stepping into sunlight after years spent in shadow, not overwhelmed, just quietly changed. And that change whispers something inside you. What else in the universe is waiting for a moment of warmth to reveal another version of itself? You don't try to answer. The question feels more beautiful without clarity. Meanwhile, the visitor's trajectory continues to evolve. Minor adjustments in acceleration still appear small enough to puzzle large enough to matter. Radiation pressure plays its part. Surface outflow plays another. Electromagnetic interactions weave their soft forces through everything. Nature writes equations. You feel poetry. Somewhere inside this mixture of physics and wonder, your heart recognizes a pattern, not in the data, but in how you respond to the data. The visitor has become more than a distant object. It has become a mirror showing how your curiosity opens when faced with mystery that doesn't threaten you. Mystery that feels safe to explore, soft enough to hold deep enough to get lost in without fear. You sense this shift clearly when new images arrive, images showing the visitor emerging from a denser stream of solar particles into a smoother one. The halo contracts, slightly light curves become less erratic. The dust structures become more symmetrical. Astronomers describe the region as a plasma plateau, a place where forces weaken and stabilize, a resting place in the river of cosmic wind. The visitor drifts through it like someone exhaling after a long journey. And something about that exhale enters you. It makes you wonder whether calmness in space is rare, or whether it exists everywhere quietly overlooked, because humans tend to listen only when storms speak loudly. Here, calmness speaks softly, a steadier brightness, a smoother halo, a rotation that feels less strained. It is the universe whispering that even turbulence has gentleness hidden inside it. You think about how many times in your own life you passed through invisible storms, moments where you didn't change through force, but through a softness that arrived unexpectedly, a kind word, a quiet night, a breath that went deeper than you intended. The visitor lives in that same quiet shift now. Its journey continues, but the way you feel its motion has changed. It's no longer the anomaly, the strange outsider, the ancient shard of a lost world. It's a presence, a companion in the night sky, a reminder of how small motions can reshape a destiny gradually without noise. Scientists publish another analysis, this one, exploring the possibility that the visitor's interior may contain voids that collapse slightly under changing thermal stress. These collapses would not fracture the object. They would simply redistribute mass enough to alter rotation subtly. You imagine that happening, small rearrangements deep inside, quiet shifts, a subtle restructuring that no eye can see. And you feel the question inside you deepen. How much of who we are changes quietly beneath the surface without ever announcing itself? The visitor doesn't answer. It doesn't need to. Its silence has always carried more meaning than words ever could. Another data set arrives this time from night sky spectropolarimetry. It reveals a faint increase in polarization consistency across certain wavelengths, a sign of surface particles settling into new orientations. This means the visitor is not static. It adapts. It absorbs. It becomes something slightly new with each region it crosses. The universe does not require permission to change us. It only requires time. You feel that truth settle inside you with a warmth that has nothing to do with stars. As the visitor continues drifting through the calmer stretch of solar wind, a soft glow appears around parts of its halo. Not brighter than before, just steadier, as if the dust has found a brief equilibrium. Some researchers describe this as photonic relaxation, a term rarely used referring to dust grains reaching a stable charge balance reflecting light more consistently. But you feel it differently. You feel it as the visitor learning how to exist here. Not perfectly, not permanently, just gently. And this is when the real question inside you finally forms soft, shapeless trembling at the edges, like something new being born. It doesn't ask what the visitor is. It doesn't ask where it came from. It doesn't ask whether it will remain mysterious forever. It asks something quieter. Why does something so old and distant feel familiar to you? Why does its glow feel like memory instead of discovery? Why does its silence feel like company? Why does its journey feel like a reflection of your own, moving through invisible forces? You cannot name shape gently by conditions you never chose, becoming softly different every time light touches you. The universe doesn't offer answers. It only leaves questions in you the way tides leave patterns in sand. And somehow, the question itself becomes enough. As the visitor drifts onward, you feel the space between you and the stars grow thinner. Not physically, but emotionally, a soft transparency where wonder passes freely unbothered by the need to be solved. Somewhere deep in your chest, the question remains. Not heavy, not urgent, just glowing with the faint, steady light of something waiting to be understood when you are ready. You rest with that question the visitor left inside you, that quiet, trembling feeling, asking why something so ancient, so distant feels familiar. It lingers softly without pressure, the way a warm memory lingers on your skin long after a gentle touch. As you breathe with it, the visitor continues drifting through the calmer stretch of the heliosphere, its halo smoothing its motion, easing its light, breathing with a steadiness that feels almost like relief. And somewhere inside that stillness, a realization begins to form. Not sharply, not suddenly, but slowly, like dawn dissolving into view long before the sun rises. You start to see how nothing in space ever travels alone. Even the visitor wandering for millions of years through interstellar dark was never untouched. Cosmic rays carved it, passing stars nudged it, molecular clouds coated it, gravity from distant systems pulled at it, and now the sun warms it. Loneliness in space is a story humans tell. The universe never agreed to it. You notice this truth when fresh data arrives from multiple spacecraft. The visitor is entering a region where the heliospheric current sheet, the vast wavy structure that divides the sun's magnetic polarity, runs closer to its path. This sheet is thin, but immense, stretching billions of kilometers, rippling like a soft ribbon through solar wind. Objects passing near it feel changes in magnetic direction, subtle tugs, rotational nudges barely measurable. The visitor feels these tugs, not as force but as company. Its dust halo aligns just slightly with the shifting field, as though responding to a whisper. Light scattering patterns evolve, edges softening brightness, settling into a quieter glow. You sense that glow the way you sense the warmth of someone sitting beside you, not touching, just close enough for your breath to change. Scientists map these magnetic ripples and notice something beautiful. The visitor's path threads between regions of opposite polarity, where particles flow differently, where the sun's influence organizes itself into alternating spirals. Between these spirals, the visitor moves like a seed carried between soft currents of wind. A seed is not alone when wind carries it, nor is the visitor. Further out, spacecraft detect the resonance of plasma oscillations, tiny waves flowing through the heliosphere. When the visitor crosses these waves, its dust halo vibrates faintly, creating small variations in reflectance. To you, the effect feels like hearing a distant hum too soft to identify, yet present enough to remind you that silence is never truly silence. Even emptiness carries music. Meanwhile, infrared sensors detect the visitor's temperature fluctuating gently, not from chaos, but from passing through zones of varying solar wind density. It warms a little, it cools a little, it breathes in its own way. Temperature fluctuations. This subtle are usually ignored in textbook descriptions of interstellar bodies. But here amidst the sun's influence, they reveal something profound. Even something shaped by ice and void responds to the warmth of a star. And as this truth settles into you, another realization comes, one shaped by science but felt in your bones. Everything in the universe is held by something. Objects held by gravity, dust held by charge, light held by curvature, particles held by magnetic fields. You held by the quiet awareness of this moment. You feel that holding now, soft and supportive, like a friend leaning gently into your shoulder. New simulations from heliophysicists show how the visitor's path will curve as it approaches regions where the solar magnetic field tightens. The curves are subtle, delicate, beautiful, in the way they echo orbital harmony without ever becoming captivity. The sun does not trap the visitor. It greets it, guides it, touches it lightly enough to be remembered, but not enough to take away its freedom. You think about how rare that kind of touch is, a force strong enough to shape you, yet soft enough to let you continue becoming yourself. The visitor experiences that now. Its rotation slows by a fraction, likely from asymmetric sublimation of deep volatiles molecules, warmed enough to escape quietly changing momentum in a way no one sees, only measures. The process is natural, gentle, inevitable for anything exposed to sunlight after so long in shadow. But the meaning you feel from it is deeper. The visitor isn't dissolving, it's adapting. You realize then adapting is another form of not being alone. Every change it undergoes, every particle it releases, every photon it reflects is a conversation with the environment. Interaction is connection. Connection is belonging. Even for an interstellar traveler. This is when the quiet realization solidifies inside you. Not sudden, not sharp, just tranquil, warm, like a truth that has been waiting for you to slow down long enough to hear it. Nothing in the sky is ever truly alone. Not comets, not dust, not planets, not light, not you. Even the darkest, coldest object drifting for millions of years still carries imprints of everything it has touched, everything that has touched it, everything it will touch again. Its solitude was never emptiness. It was simply distance waiting to become closeness under the right conditions. You breathe slowly, feeling the weight of that thought settle into your chest like a soft stone warmed by someone else's hand. Somewhere in the new data, a surprising detail appears. The visitor's halo brightens slightly when passing through pockets of enhanced solar wind density regions, created by interactions between different solar streams. The halo doesn't brighten because the visitor decides to glow. It brightens because particles around it reflect more light when energized. This brightness is not loneliness, it is response. A sign that even the smallest grains surrounding the traveler are listening to the universe and answering softly. Just like you. As the visitor moves deeper into the sunlit regions, gravitational influences shift, electromagnetic textures swirl, dust rearranges, light steadies. Everything touches everything. And you begin to realize that perhaps the question inside you never needed an answer. It only needed space to unfold its shape. A shape that looks very much like connection. A shape that feels like belonging. A shape that whispers. You are part of this universe the way the visitor is part of it. You respond, you change, you glow when touched by warmth. You are not as alone as you sometimes believe. The visitor continues drifting its halo, gently shimmering in the sun's breath. Each motion elegant, each interaction soft, each fragment of light, a reminder that even the farthest traveler finds company eventually. And as you follow its journey with your inner quiet, You feel the realization complete itself, not as a statement, not as knowledge, but as comfort. Nothing that moves through the universe ever moves alone, not even you. You stay with that realization a little longer, that nothing in the universe ever truly moves alone, that even an ancient traveler shaped by silence carries traces of every force that ever brushed against it. The feeling settles gently inside you, warm and steady, like a hand placed softly over your heartbeat. And just as that warmth deepens, the visitor begins to drift out of the sun's most vibrant influence. Not abruptly, not with finality, just slowly the way evening light fades from a window without announcing its departure. Measurements from heliophysics missions show the solar wind thinning ahead, density dropping turbulence, softening magnetic ripples, smoothing into wider, quieter arcs. This is the region where the sun's breath loosens its hold, where objects begin to return to the vastness between stars. You feel this shift as though it's happening in you, too. A soft uncoiling, a gentle release, a readiness to drift without resistance. The visitor's dust halo follows this change. It expands slightly as charged particles become sparser. Brightness spreads into a softer glow. Edges blur delicately light, becoming less of a reflection and more of a memory. Infrared instruments detect tiny drops in surface temperature, signaling the beginning of a slow return to deeper cold. It's not a retreat. It's a settling a body easing back into the environment that shaped it for so long. You imagine that cold like a soft blanket, not harsh, not lonely, just familiar in a way warmth never needed to be. As the visitor drifts farther outward, its motion becomes governed less by forces and more by freedom. Radiation pressure weakens. Magnetic interactions fade. The sun's gravity still holds it, but gently now, the way a parent holds a child's hand while letting them wander just far enough to feel independent. Trajectory simulations show a gradual arc that will carry the visitor away from the plane of planets into the broader stillness of the heliospheric outskirts, a region where cosmic rays brighten, where solar particles stretch thin, where the boundary between one star's influence and the galaxy's breath becomes a soft, shimmering gradient. You picture that place a border made not of lines but of transitions so gradual they feel like exhalations. The visitor will cross that border someday, not soon, not dramatically, just naturally in the rhythm of a journey that began long before Earth existed. Before it reaches that distant edge, another effect emerges. Spectrographs reveal changes in the visitor's reflectance, subtle increases in wavelengths associated with crystalline restructuring. As it cools again, surface molecules settle into new arrangements, locking in memories of the sun's warmth, the way stone carries echoes of fire long after flames have vanished. You hold that image softly, light turned into memory, warmth turned into structure, experience turned into quiet resilience. And something inside you responds to that truth with a tenderness deeper than understanding. Because you change the same way. Not through dramatic moments, but through soft ones that rearrange you, slowly unseen. By others felt only when you pause long enough to notice the shape you've become. More data arrives from long-range telescopes. The visitor's brightness curve becomes smoother, less influenced by solar wind. The halo grows faint dust, dispersing into the heliosphere until it becomes part of the sun's endless drift. Some of that dust will travel for decades before touching anything again. Some will spiral in delicate arcs before dissolving into charged particles. Some may join the stream of interstellar grains that wander through the galaxy in quiet anonymity. Every piece carries a fragment of the visitor's story. Every grain continues the journey in its own direction. You realize then that departure is not the same as ending. Sometimes it's simply dispersal, a story becoming many stories, light becoming many lights. The visitor continues onward, slowly leaving behind the planets, the fields, the magnetic ribbons, the warmth that reshaped it. But something in you knows the traveler isn't moving away from meaning, it is carrying meaning with it. Meaning that came from being seen, from being measured, from being held briefly by a star and the minds of those who witnessed its passing. You imagine the visitor drifting through calm plasma halo, dissolved surface cooling into ancient silence once again. No turbulence, no brightness, just the soft soundlessness of space wrapped around a body that has known both dark and light. There's a strange comfort in knowing it will continue long after you stop thinking about it, just as there is comfort in knowing your own journey continues through moments too quiet to notice. New studies suggest the visitor will eventually reach a region of the heliosphere where interstellar neutral atoms mix with solar particles. This boundary, the outer skin of the sun's influence, is where objects experience a change in particle flow, a gentle shift in pressure, a faint increase in cosmic rain. The visitor will pass through that rain, like someone stepping into soft mist, its surface absorbing what it must, reflecting what it can, surrendering the rest to the infinite dark beyond. And in that moment, the question inside you dissolves into something softer. Not why the visitor feels familiar, but how. How something so distant can stir something in you. How a silent traveler can awaken quiet truths inside your own orbit. How light reflected off an ancient shard can become a mirror for the things you don't always let yourself feel. You realize the universe has been speaking to you gently through the visitor, not in words, but in patterns of motion and light. Whispering that distance is not separation. Whispering that silence is not emptiness. Whispering that even things drifting alone carry the touch of everything they've met. You breathe slowly at that thought, letting it fill the space beneath your ribs with a calm too deep for language. Eventually, the visitor becomes too faint for any instrument to see. Its glow blends with distant stars. Its path becomes just another line in the darkness. Its presence fades into the quiet truth of all things that move beyond sight. But inside, something remains, a gentle awareness that not everything must stay visible to stay meaningful. You close your eyes, you feel the softness of the universe settle around you like a blanket drawn from starlight. The visitor drifts on, and somehow you feel yourself drifting with it, unhurried, unafraid, at peace. The story doesn't end. It simply becomes quiet enough for you to sleep beside it. And in that quiet, you hear the universe breathe.